decided to create a circuit using a graphite pencil that we obtained from the art room. Graphite is known to have a fairly high conductivity, so we thought we'd see what happens when we hook it up to, in our first case, a 120 volt power source, and later to an 8.2 volt battery. In our first experiment, we hooked up our circuit consisting of basically an ammeter to measure current and our resistor, namely a 15 centimeter long graphite pencil with a wood coating around the graphite itself. And we hooked that up to a circuit board in the physics lab, which was connected to a power source of 120 volts. Clearly, that's a lot of voltage going through that circuit. So unfortunately, as soon as we got going, we actually blew a fuse because the voltage was so high. Now that makes sense because we didn't have a lot of time to read from our ammeter because the fuse blew so quickly. But the ammeter reading was high, our voltage was 120 volts, and when you multiply those values together to get power, you get a very large wattage. And with a wattage that large, the circuit was just not able to handle it and the fuse blew. So therefore our first experiment involving the graphite pencil circuit was unsuccessful. So after our initial blooper involving the fuse, we decided to modify our experiment a little bit, and we replaced our 120 volt power source with a 9 volt battery. Now we used a voltmeter to measure the battery, and the battery only had about 8.2 volts going through it. So we accommodated that in our circuit. And this is kind of a graphical representation of our circuit. We'll explain the process by which we obtain these values shortly. But basically the circuit, as we said, had 8.2 volts going through it. Our current was 0.41 amps, and we had one resistor, the graphite wood-coated pencil, which had a resistance of exactly 20.0 ohms. As we mentioned earlier, we used an ammeter to calculate the current flowing through our graphite pencil circuit. Our current value was 0.41 amps. We also used a voltmeter to calculate 8.2 volts entering the circuit from our power source. Now, in order to find the resistance that the graphite pencil was containing within our circuit, we needed to use Ohm's law, which states that voltage equals current times resistance. And from there, we turn that into resistance equals voltage divided by current, and we inserted our measured values, 8.2 volts divided by 0.41 amps, to produce a resistance value of exactly 20 ohms.
Okay, so next we have to solve for the resistivity. By doing this, we use the resistance equation, which is equal to resistivity times length over the cross-sectional area. We know that the resistance is 20 ohms. The length of the pencil being 0.15 meters, and the radius being 0.0015 meters. To determine the radius, we broke the pencil in half and measured the diameter of the graphite. We then took the diameter and divided it by 2 and plugged it into our equation, which came out to be 9.4 times 10 to the negative 4th ohms per times meters.
So as you can likely tell from our resistivity value, graphite, basically a solid form of carbon, is not a everyday material that's used as a conductor. Even though it's a very conductive substance, it's not nearly as good as something like carbon, which has an approximate resistivity value that we found online of about 1.6 times 10 to the negative 8 ohm meters. And while there's a lot of factors in place that can produce a different resistivity value here from graphite resistivity values that you'll find online, namely the difference in cross-sectional areas and difference in length, this is still a fairly decent metric indicating that a graphite pencil and graphite in general are not ideal conductors. While they do conduct electricity, they are not the best of the best. Something we wondered about when doing our experiment originally was if we could create a circuit on paper by drawing in graphite. And unfortunately, when we were using the 9 volt battery, we didn't have enough voltage to make it happen. Now, inspired in part by that question on the test, we're going to hook this up to the 120 volt power supply and see what happens when we try to create this circuit. So Ryan, if you could activate the circuit.